Hello, in today's video we're going to be talking about balancing equations. Now we're getting into the true aspect of chemistry. I'm going to be giving you guys at first the actual reactions, so you don't have to worry about figuring out what the reactants are or what the products are. But starting next week, I'm going to have you guys predict what the products of a certain reaction are going to be. So we're rapidly moving through this, but we're going to start low level first, where you're just going to have to balance an equation, and then we're going to move up to where you're predicting the products and balancing equations and doing conversions. So for right now, I just want to figure out how to balance an equation. So let's take that same octane that we saw on the previous video, C8H18, and let's burn that. Let's combust that. Let's introduce oxygen and see what we produce. We're going to introduce oxygen, and remember, oxygen is a diatomic, so it's going to be always found as O2. So this is where people get tripped up a little bit. They'll put an O rather than an O2. Remember, all diatomics have to have a subscript 2 in a reaction. So these are our reactants. We're going to have our yield arrow, which is the arrow that tells you the reactants are on the left, the products are on the right. So the products of this type of a combustion is going to be CO2 plus H2O. And in this case, octane will be a liquid, oxygen would be a gas, CO2 would be a gas, water would be a liquid. Now right now, you don't know where these came from. You haven't seen enough of these types of products and reactants to identify what their state of matter is, but for right now, you don't have to. I will give that to you. So here, let's set up a counting system, the reactants and the products. And let's count the number of each of the elements that are present. So carbons, we know we have 8. Hydrogens, we have 18. And oxygens, we have 2. Now, in order for the law of mass conservation to hold, the number of atoms on the left of each element has to equal the number of atoms on the right. So if these numbers match the numbers on the right, we're done. If they're not, we're going to have to do something special. So we perform the same type of thing over here, where we calculate and count the number of each of the elements. There's 1 carbon, there are 2 hydrogens, and there's a total of 3 oxygens. The carbon dioxide gives you 2, the water gives you 1. So we have 3 oxygens. Clearly, this is an unbalanced equation. So now what we need to do is we need to somehow balance this equation by putting stoichiometric coefficients. Stoichiometric coefficients are the big numbers that go in front of the compounds. Those numbers do not do anything to the subscripts. The subscripts remain the same. The compound, the molecule, never changes when adding in stoichiometric coefficients. However, we will have to distribute that when counting. So we know that we had 8 carbon atoms on the left, we only have 1 on the right, so let's put 8 in front of the CO2. This is a big number. It didn't change my CO2, but now we're going to have this 8 is distributed to everything. So 8 times 1 is 8. 8 times 2 is 16. So the 8 got distributed to the subscript here, and when we're counting, and that gives us 16 total oxygens plus 1. That adds up to 17. So if you notice, I recount everything as I change one of the numbers. You'll have a lot of forwards and backwards type of thing. If you notice, I could have started by balancing the oxygen. However, it's a good idea to leave the oxygen to the end because it's by itself on one side or the other. Since it's an O2 over here, it'll be easy to balance it at the end. So I'm going to leave that till the end. Next, let's balance the hydrogen. We had 18 on this side, we had 2 on this side. So if I put a 9 here, that makes it 18. So now our hydrogens and carbons are balanced. Our oxygens, this is 16 plus 9 is 25. Well, we only have 2 oxygens over here, 25 over here, so we need to put a stoichiometric coefficient. The stoichiometric coefficients for this class are going to always have to be whole numbers at the end. But initially, you can add fractions. So the easiest way to get rid of this 2 would be to multiply 25 halves by 2. That would give me 25 on this side. It is a balanced chemical equation at this point. However, this is an ugly equation for general chemists. We want to have whole numbers here. So what I can do is I can multiply the entire equation by the denominator. So now what I get is this 2 is distributed, So now I have 2 here. The 8 gets canceled, turned into 16. 18 times 2 is 36. The 2 gets distributed here. This goes away. I now have 50 oxygens. The 2 gets distributed here. I now have 16 carbons plus 24 oxygens plus 9, which is 33. I think I'm doing that. No, 43. I might have made a mistake with my addition there. And the 2 gets distributed there, which is 18. I know at the end that it's all going to add up, so it's not a big deal. So now this is now not 18, this is 36. This becomes 50, and we have 16, 16, 36, 36, 50, 50. Everything's in a whole number up in the stoichiometric coefficients, and this is a pretty balanced chemical equation. This is how you're going to end all of your balanced chemical equations. And with that, that's all I want to talk about for balancing a chemical equation. See you all in class tomorrow.